Hello, Lovelace. Welcome to today's maths lesson. Now we're carrying on with our theme of fractions, but today, as you can see from my question, it's can I understand number sequences? Okay, remember, a number sequence is a string of numbers with a particular pattern, particular step between them. But we're going to look at that within our fraction topic. Okay, as usual, little warm up just to see if we're all switched on. 3 questions there. Pause the video and have a go at those. Okay, let's take a look. Number 1, how many terms are shown in this sequence? We've got 15, 18, 21, 24, and 27. Now, this is all about the language of the question. How many terms? Now, the term in this case is the number of items in the list. So, in this case, we've got 5 terms. There are 5 items in our list. Number 2, what is the rule for this sequence? So you need to look at the steps in between. What happens to each number in turn to get to the next number? We've got 32, 16, 0. So clearly the sequence is going down. We're subtracting. But how much are we subtracting each time? Well, to get from 32 to 16, we would subtract 16. To get from 16 to 0, we would subtract 16. So our rule here is subtract 16. And finally, what's the next consecutive integer after 19? Again, this is all about the vocabulary, the language. So 2 words here that we need to understand. First is consecutive. Now, consecutive means it follows on. It's the next along. Okay, so 1, 2, 3 are consecutive numbers. 7, 8, 9 are consecutive numbers. They follow on from each other. So the next consecutive integer. Well, an integer is a whole number. So basically, although it's very wordy, all this question is asking you is what's the next number after 19? It's 20, okay? But consecutive means it follows on, it is the next one in the sequence. An integer is a whole number, okay? Right, here we have the start of a sequence. We have 1 and 1/4. And you can see here with the diagram, we've got the whole one, 4 quarters, and then 1/4. We've got 1 and 2/4. So there's your whole one, there's your 2/4. So next in the sequence, because as you can see, we've added a quarter from the first item, from the first term to the next term, we've added a quarter. So the next term along, we added another quarter, then another, then another. Okay, so our missing numbers, first of all, using the diagram, we've got the whole one, and then this time we've got 3/4. So that's 1 and 3/4. A whole one and 4/4. So 1 and 4/4, which of course we know is actually the same as saying 2 whole ones. And then 2 whole ones and 1/4. Okay, so there's our sequence. We've increased, we've added 1/4 each time. Right, here's another sequence where we've got some of the items, some of the terms are in place, but not all of them. So what's going on here? Well, first of all, let's look at the information we've got. We've got 1 and 2/3, and we've got 2 and 2/3. So this big step is a whole one. Okay, so we've added a whole one. But if we then look at the separate steps in between, how big is each little step? Okay, so what is that step worth? How much have we added this time? Have a think. Okay, well, hopefully you've realized that we've got 1, 2, 3 steps within this whole one, which basically means that we're going up in thirds each time. We've added 1/3. So we've got our 1 and 2/3 in diagram form. Then we've got 1 and 3/3, which is the same as 2 whole ones. Then we've got 2 and 1/3. Then 2 and 2/3 we've already got in place. Our missing one here will be 3 whole ones. Then 3 and 1/3, and finally 3 and 2/3. Okay, each small step we have added 1/3. Right, now on the top of this number line, we have got improper fractions, and on the bottom, we have got the mixed number, but they are the same value, they are the same amount, okay? But let's look at the step first of all. So we've got 5/9 here and 7/9. So what's the step between 5/9 and 7/9? It's 2/9. So we've increased by 2/9. And if we increase by another 2/9 and another 2/9, and we're going to go 5/9, 7, 9, 11. Go on, keep it going. What's going to come next? Right, hopefully we've realized that the denominators remain the same. We don't need to worry about those. So it's just the numerators. So we've got 5/9, 7/9, 9/9, 11/9, and then they're the remaining ones: 13, 15, 17, 19, and 21/9. Okay, but what do they look like as mixed numbers? We've been doing those in recent lessons. So here's a chance for you to practice that. What is 13/9 as a mixed number? We ask ourselves, how many nines in 13? Well, there's one. So we've got one whole one, and then there's 4 remainder. So we've got 4/9. So 1 and 4/9. 15/9 is 1 and 6/9. 17/9 is 1 and 8/9. Now we get to 19/9. Now we could be very lazy and say 1 and 10/9, but it wouldn't just be lazy, it'd be wrong. How many nines in 19? Well, there's 2. So we've got 2 whole ones and then 1 remainder. So it's actually 2 and 1/9. Don't fall into that sort of trap of being lazy and just keep adding 2. You've got to be paying attention to see if we go to the next whole number. And in this case, we do. And then the final one, 2 and 3/9. Okay. So always be careful when you're getting close to the numerator matching the denominator, because you're getting to the next whole number. Okay. But in each case here, we've increased. Our step has been plus 2/9. Well done. Right, your turn. We've got 3 questions here for you to have a go at. The first question 1, we've given you the diagram, the bar chart, together with mixed numbers. Can you complete those 2 sequences, please? Number 2, we've got the improper fraction on the top. We've got the mixed number on the bottom. Can you complete those number sequences, please? And then finally, number 3, we've just got the mixed numbers here. Complete the sequence and then tell me what's the same and what's different about B and C. Okay, pause the video, have a go at those 3 questions. Right, let's take a look. Remember to mark your work, please. So 1A. Well, we're going up in 1/5. We've added 1/5 each time. 1, 1 and 1/5, 1 and 2/5, 1 and 3/5, 1 and 4/5, and then 1 and 5/5, which we know is the same as 2 whole ones. Okay, and then the diagrams, we're just missing that 1 and 4/5. So your diagram should look like that: 1 whole one and then 4/5. On B, we need to look at what the step is. This time, we've gone from 1 to 1 and 2/5. So we're adding 2/5 each time. So 1 and 2/5, 1 and 4/5. Now, 1 and 6/5 obviously is not the way we present this. It's the same as 2 and 1/5, 2 and 3/5, and then instead of 2 and 5/5, it's 3 whole ones. Well, our diagrams will help us along the way with this. So you can see 1 and 4/5, the whole 1 and 4, 2 and 1/5, 2 whole ones, and 1. We've added 2/5 each time. Right, question 2, your number lines. If we look on the top, first of all, at the improper fractions, we've gone 4/7, 5/7. Okay, so we've gone up 1/7 each time. 4, 5, 6, 7, 8/7, 9/7. And then on the bottom, same step, 4/7, 5/7, 6/7. Then 7/7 is the same as a whole one. 1 and 1/7, 1 and 2/7 is the same, is equivalent to 9/7. On B, We've got 14 sevenths, 17 sevenths, 20 sevenths. We've added 3 sevenths each time. So let's carry on that top row to 23 sevenths, 26 sevenths, 29 sevenths. And then on the bottom, we need to check for the equivalent mixed number. The 14 sevenths is the same as 2. 17 sevenths is 2 and 3 sevenths. 20 sevenths is 2 and 6 sevenths. 23 sevenths is the same as 3 and 2 sevenths. 26 sevenths is 3 and 5 sevenths. And 29 sevenths is 4 and 1 sevenths. Big ticks there if you got those. Well done. And to see on the top row, let's look at this end of the row because there's more information there to help us. So we've gone 15, 12, 9. So we've gone down 3 eighths each time. So we are subtracting 3 eighths. So let's go back to the beginning and fill in our missing 2 here. 24 eighths, take away 3 eighths becomes 21 eighths, becomes 18 eighths. Okay, so there's our top row complete. And then we've got the whole bottom row to fill in, converting improper fractions to mixed numbers. Well, 24 over 8 is 3. 21 over 8 is 2 and 5 eighths. 18 over 8 is 2 and a quarter. 15 over 8 is 1 and 7 eighths. 12 over 8 is 1 and a half. And 9 over 8 is 1 and 1 eighth. Well done if you've got those 3 correct. Make sure you're marking these and also make sure you're putting in any corrections that you need to make. Okay. Right. Here we have, oops, sorry, I skipped straight past number 3. I apologize. Right, number 3, here we've increased by 2 eighths each time. So there are your missing numbers. A, increased by 2 eighths. We get to 3 and 1 eighth, 3 and 3 eighths, 3 and 5, 3 and 7, and 4 and 1 eighth. B, this time we're going down by 3 sevenths. So we're subtracting 3 sevenths each time. So 5 and 6 sevenths, 5 and 3 sevenths. 5, which I'll say instead of saying 5 and 0 or no sevenths, we just say 5. And then 4 and 4 sevenths, 4 and 1, 3 and 5 sevenths. And C, we've gone down by 3 elevenths. So 6 elevenths, 5 and 3 elevenths, 5 and 0 elevenths. So we just say 5. 4 and 8 elevenths, 4 and 5 elevenths, 4 and 2 elevenths. So what's different and what's the same about these two, B and C? Well, the same is that we're reducing by 3 lots of whatever the fraction is. So in both cases, we've subtracted 3 lots of. So our numerator is subtracting 3. The difference is that this one is dealing with sevenths, this one is dealing with elevenths. Okay, so we're taking the numerator that we're subtracting is the same, the denominator is different. Right, here we have the start of another number sequence. We've got 6 and 1 eleventh. We've got 5 and 8 elevenths. So our first job is to work out what the step is. We're clearly going down. We've got 6 whole ones here and 5 whole ones here. So it's subtract. Well, how much do we subtract? Well, if we subtract 1 11th, we'll get down to 6. 2 11ths would be 5 and 10. 3 would be 5 and 9. So 4, we're subtracting 4 11ths here. So there we go. So 4 11ths subtracted each time. So let's keep going. We've got 5 and 4 11ths. What's the next one? Okay. Hopefully no one is saying 5 and 0 11ths. We just say 5. And if we take away another 4 11ths, we're going to be left with 4 and 7 11ths. Okay. Slightly trickier maths, but exactly the same idea. We find the step and we work it through each time. And remember, diagrams can always be drawn if that just helps you along the way. If you're still a little bit unsure with some of these, then draw them out. Draw the bar chart to help you understand the fraction. And then rub some out, take some away. Okay. So what is the rule for this particular sequence? We know what the step is, and that step tells us what the rule is. We are subtracting 4 11ths. Okay, so that's the rule. Okay, we've got 1, 2, 3, 4, 5 terms. Remember from the beginning, a term is how many items in the list. We've got 5 terms, but the rule is what's the step each time? What do you do to those numbers? So our rule here is to subtract 4/11ths. Now, what's going on here? We've got 2 whole numbers, but we've got 3 missing numbers in the middle. So clearly these are going to be mixed numbers, but what are they going to be? Now, we've got our little minion fella here telling us that there are 3 boxes, so the missing fractions must be thirds. Do we think he's right? Well, let's have a look. Okay, we've got the first and the 5th term, and they're consecutive integers. We've got 11 and 10. So 11 and 10 follow on from each other. Okay, but it's the first and the 5th term because we've got 1, 2, 3, 4, 5. So if we've got 5 steps, so 11 is our first step, 10 is our last step, then we've got our 3 steps in the middle, but altogether there's actually 4 steps because we need to count the last one. So 1, 2, 3, 4 steps to get from 11 to 10. Now, if there are 4 steps, then it's not thirds, it is quarters. Okay, so each step is a quarter. So he was wrong. Now, what's the rule for this sequence? And what are our missing numbers? Well, the rule is we are subtracting quarter. So there are our missing numbers. Now, some of you may realize that we can write 10 and 2/4 in a different way. But we are subtracting 1/4 each time. So there you go. 10 and 2/4 is the same. It's equivalent to 10 and a half. Okay? Doesn't make it wrong if you leave it as 2 1/4, but it's a much tidier fraction. 10 and a half is a nice way to simplify your answer and make it, I suppose, more precise. Right, your turn again. 3 questions again. On question 4, we've got 4 sequences. I'd like you to draw a line to match each one to the rule. So what's going on in each sequence? On number 5, okay, we've got 3 at this end of the sequence and 4 at this end of the sequence. Now, Teddy thinks they're in sevenths. Is he correct? Yes or no? So once you've figured that out, I want you to complete the sequence from 3 to 4. Now, Rosie thinks that one of the missing fractions is the same as 3 1/2. Is she right? And explain it. Okay. And which other equivalent fractions can you spot in that sequence? So are there any ones you can simplify? And finally, question 6. We've got Amir who's thinking of a number sequence. The first and 4th terms are consecutive integers. So you need to write a rule for his sequence. Okay. Pause the video, have a go. Okay, your answers. Our first sequence, 2 2/3, 3 1/3, 4. Well, in this case, we're going up in 2/3. So 2/3 is your first answer, adding 2/3. For our next one, 2 1/4, 3, 2 1/2, 3 1/4, 4. In that one, we're going up again. So we're adding 3/4. The next one, 4 1/3, 3 2/3. So we're going down and we are subtracting 2/3. And finally, 4 1/4, 3 3/4, 3 1/4. Again, we're going down. So we're subtracting. And in this case, we are subtracting 1/2. On question 5, Teddy thinks that these are in sevenths because there are 7 cards. But if you remember from our 3rd and 1/4 question earlier, it's actually going to be there's one more step here. So the steps are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 steps to get us from 3 to 4, which means that we're going up in 8s, not in 7s. Okay. So that means that the completed set sequence will be 3, 3 and 1/8, 2/8, 3/8, 4/8, and so on, all the way up to 3 and 7/8, and finally to 4. Now, Rosie thinks one of these is equivalent to 3.5. Is she right? Well, yes, she is. The one in the middle, 3 and 4/8, 4/8 is equivalent to a half. And we know that because if we divide top and bottom by by 4, 4 divided by 4 is 1, 8 divided by 4 is 2. So 3 and 4/8 is equivalent, is the same as 3.5. And D, are there any other fractions? Which other fraction sequence can you find an equivalent for? Well, you can go bigger with any of them. But let's just look at the ones we can make simpler, smaller. Well, 3 and 2/8 is the equivalent, is the same as 3 and 1/4. And 3 and 6/8 is equivalent to 3 and 3/4. Okay? Or any of them we can make much bigger fractions, bigger numbers in the fraction and stay equivalent. But those are the only two other ones that we can make simpler, we can make smaller. Right, finally, number 6. Amir, he's got his the first and fourth terms are consecutive integers. Okay, so for example, we've got 1, and then we've got 2 boxes, and then the fourth term could be 2. So 1 and 2 are consecutive, and then there'd be 2 boxes in the middle. That means that we've got 3 steps. So we're going up in thirds. So there's his rule. For each one, or for this particular sequence, you're going to add 1/3. Okay. As usual, please check your answers. Please look at any corrections and make sure you're happy with why you've made the error and that you can say you're confident to move forward. Okay. And once complete, please make sure you're uploading to Tapestry so I get to see all this wonderful work. Okay, but that's the end of today's lesson. Take care of yourselves, take care of those around you, and I will see you all very soon.